Welcome. In this module, we will explore the fundamental building blocks of the Azure cloud, resources and resource groups. We will define what they are, how they relate to one another, and how they form the backbone of your cloud management strategy. Let's start with the most basic unit, the Azure resource. Simply put, a resource is any manageable item that is available through Azure. Whether you are spinning up a virtual machine, configuring a virtual network, or deploying a database, each of these entities is considered a resource. These are the basic building blocks of the cloud. Importantly, these resources are defined using declarative syntax, typically in JSON format, which allows you to state what you intend to create without writing complex programming commands. This class diagram visualizes the concept of an Azure resource. At the top, we have the base class Azure resource, which possesses common properties like name, type, and location. Extending from this base are specific examples: virtual machines, storage accounts, and virtual networks. This illustrates that while these services function differently, they all share the fundamental characteristics and management definition of an Azure resource. Now, we move to the container for these resources, the resource group. A resource group is a logical container that holds related resources for an Azure solution. Think of it as a folder where you organize assets that share a common lifecycle. A critical rule to remember is that every resource must exist in one, and only one, resource group. This structure allows you to manage the entire lifecycle of a solution. You can deploy, update, and delete all the resources in a group in a single operation, rather than handling them individually. This diagram depicts a resource group named Web App.rg acting as a container. Arrows point to the resources contained within it: a virtual machine, a SQL database, and a virtual network. This visualizes how distinct resource types are grouped together logically to form a cohesive unit for a specific application or workload. When defining your resource groups, the primary strategy should be based on the lifecycle. Generally, you should add resources that share the same lifecycle to the same resource group. Why? Because when you delete a resource group, you delete everything inside it. This feature is powerful for managing test environments or complex applications. Once you are done, a single action cleans up the virtual machine, the storage account, and the database simultaneously, ensuring no stray resources are left behind incurring costs. Here we see the lifecycle state diagram. We start with a provisioned resource group. Moving to active, we deploy various resources into it. The critical transition occurs at delete resource group. This action moves the state to deleting, which automatically results in all resources removed. This visualizes the atomic nature of resource group deletion. A common point of confusion is the location of the resource group versus the resources inside it. When you create a resource group, you must provide a location. This location is where the resource group stores metadata about the resources. Crucially, resources inside a resource group can be in different regions. For example, your resource group's metadata might live in West US for compliance reasons, while the virtual machines inside that group are running in East US to be closer to your customers. This diagram illustrates the geographical decoupling. The resource group metadata resides in the region West US block. Dotted lines connect it to a virtual machine in region East US and a SQL database in region North Europe. This visual confirms that the management layer, the RG, can exist in a completely different physical location than the resources it manages. Resource groups fit into a larger hierarchy of Azure management. Azure provides 4 levels of management scope: management groups, subscriptions, resource groups, and resources. You apply management settings, such as policies or budgets, at any of these levels. The level you select determines how widely the setting is applied, as lower levels inherit settings from higher levels. This hierarchy allows you to build a flexible structure to organize your resources effectively. This flowchart displays the Azure hierarchy. At the top is the management group. This flows down to a subscription. The subscription contains multiple resource groups A and B. Finally, specific resources sits at the bottom, contained within their respective groups. This visualizes the parent-child relationships where governance flows from top to bottom. Resource groups are vital for security and governance. You can apply access control to all services in a resource group because Azure Role-Based Access Control (RBAC) is natively integrated into the platform. If you grant a user access to a resource group, they automatically gain access to all the resources inside it. Additionally, you can apply tags to resources to logically organize them for billing. You can also apply locks to the resource group to prevent accidental deletion, ensuring critical assets remain safe. Finally, all of this is powered by Azure Resource Manager, or ARM. ARM is the deployment and management service for Azure, providing the layer that enables you to create, update, and delete resources. Whether you use the Azure portal, PowerShell, or the CLI, ARM handles the request. It allows you to manage your infrastructure through declarative templates rather than scripts, ensuring that you can redeploy your solution repeatedly with confidence that your resources are deployed in a consistent state. This sequence diagram shows the flow of a request. The user interacts with tools like the portal or CLI. These tools send a request to Azure Resource Manager ARM. ARM authenticates the request and forwards it to the specific resource provider, like compute or storage. Once the provider confirms the creation, ARM reports success back to the user. This illustrates ARM's role as the central orchestrator.